Greetings everyone, welcome to LogicLoops. Today we are going to discuss selection sort. In selection sort, what we do is, as per its name, we select a particular index, that is element, and compare it with all other elements in order to get the minimum of all the elements. Now we are going to discuss the code as well as example. Let's start line by line. This is a function of selection sort, that is ascending selection sort, where we are taking the nums as an input, that is nums is an array. First of all, we are calculating the length of the array. So now the length of the array is 6, that is 0 to 5. Then we are having first for loop of I, where I iterates from 0 to n, that is 0 to 5. Then we are taking one variable called as minimum index, and it is always pointing to I, whatever will be the position of I. Right now the position of I is 0, so m is 0. Then next we are having the second for loop of j, which will iterate from I plus 1 till the end of the array, which is 5 over here. Okay, so now 0 plus 1 is 1, so j is pointing to 1 and it will iterate till 5. Now in this it will compare that if nums of j, that is 2, if it is less than nums of minimum index is 0, so nums of 1, that is 2, is less than nums of 0, that is 4. Yes, the condition is true. So minimum index will be equal to j. J is 1 over here, so 0 will be cut down and m will store 1. In the same way, it will iterate the for loop. Let me quickly show you the proper code with the indentation. So here you can see, if this if loop or if this if condition is true, minimum index will be equal to j. That is, right now we have just changed the value of m to 1. Once it is completed, okay, then it will again increment the j by 1. Now j will point to its next position, that is 2. Now again check if nums of j is less than nums of m. Okay, now minimum index is pointing to j, so j is pointing to 2. Now is 3 less than 2? No, 3 is not less than 2, so again j will increment to 3. Now again it will check, is nums of j less than nums of minimum index, that is 1. Is 5 less than 2? No, it will again increment the j. Is 6 less than 2? No, it will again increment the j, and finally j would be at last index, which is 5, and its value is 0. Now again check, if nums of j, that is 0, is less than nums of minimum index, that is 2. Yes, 0 is less than 2, so 1 would be cut down and minimum index would point to 5. Now once this loop is over, it will come to this two lines. Nums of I is 4. Okay, nums of I is replaced with the minimum index. Now minimum index is stored in the m, right? So what we are going to do, we are going to just swap these two values. Okay, so 4 will be replaced by 0 and 0 would be replaced by 4. In this way we will get our first sorted array. Okay, this is our first iteration. Now in the next iteration I would be incremented by 1. So now I will be here and j would be I plus 1, that is over here. Let me quickly rough all the unnecessary part so that I can explain you. Okay, now I is pointing to 1 and j is pointing to I plus 1. Now in this case again the j will iterate. Now m is pointing to the position of I. Where is I? I is at 1. Now j would iterate from 2 to 5. It will check, is nums of j less than nums of minimum index? Is 3 less than 2? No, j would increment. Is 5 less than 2? No, j would increment. Is 6 less than 2? No, j will increment. Is 4 less than 2? No. Again j will increment. Now minimum index is already pointing to 1, that is 2. Once this for loop again ends, it will again swap the pairs. Now in this case, as there is no other smallest element, the swapping would be as it is, right? Because both are pointing to 2 only. So we will get the next sorted array. In the same way, if we do all the iteration, we will get a sorted array of 0, 2, 3, 4, 5 and 6. So as you can see over here, we are iterating all over the array. So it will take the time complexity of big O of n square. Why? Because every time we have to iterate the whole array, and we are using two loops over here, which is the for loop of outer iteration and for loop for the inner iteration. So whether it may be your best case, worst case or average case, it would take the complexity of big O of n square, and space complexity would be big O of 1 because it is not using any auxiliary space to store the array. It is in place swapping. Now let me quickly show you that how exactly the code looks like. This is the code for ascending selection sort, and below is the code for descending selection sort. Now let me quickly show you exactly how it runs. So here you can see the original array is here. This is the ascending order and this is the descending order. If you want to take the screenshot of code, you can take it. With this, thank you so much for listening this video and paying attention to the selection sort. Thank you so much.